Hello and welcome back. This is section 4.1. We will be talking about discrete probability density function, but the first objective for today is to understand the properties of discrete probability density function. But before we do that, we have to go ahead and make ourselves familiar with what does it mean by a random variable. A random variable, like the word itself describes, that it is random, a variable that is subject to change due to a chance in the event and describes the outcome or the results of a statistical experiment. We're going to talk about in detail what this means, but you have to know how do you write a random variable. You usually represent that with a capital letter, which is X or Y, but the lowercase represents the value of the random variable. Before we jump into the experiment, let's go ahead and recap what a sample space is. Sample space is all possible outcomes of an experiment, right? Discrete data is data that you can count, like how many books do you have in your bag? How many siblings do you have? You will give me the answer in 1, 2, 3, but you will not give me the answer as how many siblings do you have? 1.2. No, that's not possible. 2.5. No, that's not possible, right? So discrete is something that you can count. 1, 2, 3, 0. And discrete random variables are variables whose possible values are distinct, like 1, 12, 15, but not the decimals, like 1.22 or 3.14. Okay? So that's what discrete means. Now let's go ahead and take a look at this example. I am flipping 3 fair coins. What am I doing? I'm flipping 3 fair coins. So here on the right hand side, I have an applet opened up. So let me go ahead and flip my coins. I'm flipping the first coin, flipping the second coin, and flipping the third coin. Now you might say, Miss, what are you doing? I am flipping the coin and I'm trying to see how many number of heads I can get when you toss 3 fair coins. In this particular case, if you look at it, I have 2 heads. That is, I have a head, and a tail, which is, let's see, right here. I have a head, and a tail. Now let me do it one more time. Flip, first time, second time, and third time. If I do it this way, look what I got. I got 2 tails and a head. So I have 2 tails and a head. So I'm just trying to see how many possible outcomes can I get. So if I look at it, I can get a tail, 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 head, 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 tail, head. So these are all the possible outcomes when I flip 3 coins. So X here represents the number of heads. I can get, so if I write that down, I can get a 0 head, right? Or I can get 1 head like I have now. I can get a 1 head, or I can get 2 heads, or I can get 3 heads. You see, this is not constant. It is varying. I can get 0, I can get 1, I can get 2, I can get 3. That is why it's called a random variable that continuously changes based on how you flip a coin or what your outcome's going to be. Now, the next one is discrete probability density function. So what does that mean? Discrete probability density function. It simply describes the relative likelihood of a discrete random variable to a given value, usually with a table. Now, you might say, Miss, what did you just say? So discrete probability density function is something that gives you the probability of that particular case. Now, if you want to find the probability of 3 heads, or if you want to find the probability of 2 heads, if you want to find the probability of 1 head, you want to find the probability of 0 heads, you put all of this together under a graph, and that graph is called your discrete probability density function. Let's go ahead and take a look at it. So here I have a table that shows a probability density function. Now keep in mind, probability density function can be given to you as a table or can be given to you as a graph. You can actually make up a probability density function, but certain things that you have to keep in mind is the first column. As you can see, the first column is your variable, And the second column is the probability of this variable. So the probability of x being 0 is 1 over 12. The probability of x being 1 is 5 over 12. The probability of x being 2 is 1 over 12 again. So all different cases. So they put all the probabilities together and they give you this particular table, which is called the probability density function. Now, what are they asking me? So they said, take a look at the table below. And what is the probability that x is 2? So they're saying, what is the probability that x is 2? Now I'm going to go ahead and see where my x is 2. That is 2. What's the probability? 1 over 2. Sorry, 1 over 12. So this is simply your probability looking at your probability density function. Okay, and keep in mind, because when I add all the probabilities, my answer should be 1. When you add all your probabilities, your answer should be 1. So when I add all of these probabilities, you can go ahead and do that. You will get your answer as 1. Now let's take a look at a next example. The table shows an incomplete probability density function for a discrete random variable x. So this is my discrete random variable x, and this is giving me the number of pets per household in a large neighborhood. So somebody went ahead and surveyed everybody, and this is the probability of having 0 pets. So as you can see, majority of the people don't have any pets. And let me erase this again so you can see it better. So I have 0 pets, probability is 0.72. 1 pet is 0.02. 2 pets is 0.13. 3 pets is 0.11. Now 4 pets, I don't have any. But how do I find out? Remember what I told you, when you add all your probabilities, you should end up with a 1. So 0.72 plus 0.02 plus 0.13 plus 0.11 plus, I don't know what this number is, everything should equal to 1. Now when I go ahead and plug that in my calculator, so as you can see, when I plug the whole thing into my calculator, I get 0.98. So this entire value is 0.98 plus x should give me 1. So I know that x is nothing but 0.02. All I do is subtract this from 1. So 1 minus 0.98 gives me 0.02. And that is the probability of the value 4. Keep in mind, when you add all the probabilities and simply subtract it from 1. All right, now let's go ahead and look at the next problem. Which of the following tables shows a valid probability density function? So let me go ahead and delete everything from my calculator here. I'm going to delete it. I don't want any history. And now I'm going to see which one is the valid. When they say valid, what they're asking me is they're saying, hey guys, add all the probabilities and see if that adds up to a 1. 1/4 plus 1/4 is 1/2. 1/2 plus half is 1. So this is a valid probability density function. Remember what I did? I simply add all the probabilities. Now let's look at the next one. 0.89 plus 0.09 plus 0 plus 0.2 plus 0. Let's go ahead and try that. I'm going to go ahead and plug that into the calculator. 0.89, oops, what am I doing? 0.89 plus 0.09 plus 0.0 plus 0.02 plus 0.0. Enter. That's a 1. So yes, when I add all my probabilities, I do end up with a 1. So I know that this is a valid probability density function. Now let me look at the next one here. So you do the same thing. You simply take all the probabilities and add and see if that ends up with a 1. But wait a minute. When I look at this particular table here, I see a negative, and I know I cannot have a negative probability, so this is not my valid probability density function. So the only thing you have to look at is to see if all the probabilities add up to a 1 and see if you have any negative probabilities, because you cannot have a negative probability. Why? Remember, probability is from 0 all the way to a 1 inclusive. That means I can have a 0 as my probability, I can have a 1 as my probability, but nothing greater than a 1 or less than a 0. All right. All right, so I want you all to pay attention. This is a very interesting topic. So the next objective is finding the mean of a discrete random variable. Now you might ask, Miss, we have seen the probability density functions. Why do we need a mean? So let me go ahead and first let me explain what are different ways of saying a mean. So I might go ahead and say find the mean of a discrete random variable, or I can say find the expected value. They both mean the same. Well, mean, yeah. So the word mean and the word expected value are the same. So the mean is mu. Remember how we represent a mean? Mean of a population is mu. So expected value is the predicted outcome of an experiment after repeating over a long period of time, usually denoted by a Greek letter mu. The expected value is also known as expectation, long-term average, or long-term mean. So where does this come from? It comes from laws of large numbers. So what does that mean? The more trials you perform, the closer and closer you actually get to the theoretical probabilities predicted for an experiment. Now you might say, what? So let me ask you something. If I flip a coin, what's the probability of having a head? So probability of having a head when I flip a coin is, I'm going to pause for a second, wait for your answer, which is 1 over 2, right? And what is that? That's 0.5. Now let me show you how did they derive to this one. On the right hand side, I have an applet. So let me flip a coin. You see, I have a tail, so probability of getting a head is 0. Does that mean probability of getting a head is 0? No. I'm going to flip one more time. Again, I have a 0. No, because I have a tail. Let me flip a coin again. Again, I have a tail. That doesn't mean probability of getting a head is 0. So let me flip a coin again. Again, I have a tail. Well, does that mean this is a tricky coin? Let's go ahead and take a look. Now let me flip it 5 times. I want you to focus on this particular value here. What's happening? As I'm flipping the coin more often, I'm trying to see the probability of getting a head. And as you can see here, it is 0.55. So let me reset this and let me go back. I want you to look on this particular section here, all the way here, which says proportion. So when I flip a coin, I get a head. Does that mean the probability is 1? No. I flip another time. I get 0.5, which is true. Let me flip another time. 0.6, probability of getting ahead is not 0.6. Let me flip 5 times. Once again, focus on this number here. You see how the number is changing. Now let me flip 1,000 times and see what happens. What is this probability getting closer to? 0.5. Let me flip again. 0.5 again. Do you see that? So as I keep flipping more number of coins, I know that the probability of getting ahead is 0.5. This is called the law of large numbers. You don't just assume or find a probability based on one trial. You keep doing number of trials so that in probability your answer is accurate. So let me reset this again. Flip a coin once, probability of getting ahead is 0. No. Flip a coin another time, probability of getting ahead is 0.5. Not with just 2 coins. I'm going to flip 1,000 times. And what is this getting closer to? 0.5. And that's how you find the expected value or the value the mean, which is you do number of trials and then come to a value, come to a conclusion that if I flip a coin 2,000 times, then the probability of getting ahead is 0.5. So that means the probability of getting ahead when I flip a coin once is 0.5. Now that we have looked at that, now let's go ahead and take a look at how do I find the probability or the expected value. Now you might say, Miss, I can probably flip 1,000 times. There has to be a method. That is correct. We do have a method. So finding the probability of finding the expected value, which is the mean. So the mean, the expected value or the mean, which is called mu. Remember, this is the mean of a discrete random variable. This is the mean of a discrete random variable, is calculated by the formula. So where is the formula? So the formula is you simply multiply x times the probability. So you multiply x times the probability and find the sum, which is the summation. Let's go ahead and take a look at the example. Again, this formula is for a discrete random variable. This formula is for a discrete random variable. Now, a team plays soccer 0, 1, or 2 days per week. The probabilities that they play each number of days per week are shown in the probability density function. How do I know this is discrete? Because look at my x value, 0, 1, 2. That's a discrete number. So the probability of playing 0 times a week is 0.2. The probability of playing 1 times a week is 0.5. The probability of playing 2 days per week is 0.3. How do I calculate the mean? The formula is x times p of x. So it's 0 times 0.2, 1 times 0.5, 2 times 0.3. So remember how I calculate my mean? First I multiply x times p of x and then I add everything. So 0 plus 0. There's another point here, 0.5, right? Plus 0.6. So when I add everything, I end up with 1.1. Now the question is, what is this 1.1? Is this the probability or is this the mean? What are they asking me? They're asking me for the mean. So what you calculated is the mean. Now you might say, what does that even mean? So remember what they asked you. They said the average number of times that the soccer players play per week is 1.1 days. How did you get the value? Based on how many days they play in a week. That is 0 days, 1 days, and 2 days. So on the average, if I calculate, these soccer players play 1.1 day per week. So this is not the probability. This is the expected value, which is also known as your mean. So your expected value. So soccer players are expected to play 1.1 days per week. So always try to analyze what the problem is asking you and what the answer that you got. Now for the next one. A casino features a game in which a weighted coin is tossed several times. The table shows the probability of each payout amount. It says assume the remaining probabilities has a payout of 0, so the probabilities add up to 1. Remember, that's the condition. To the nearest dollar, what is the expected payout? Again, they're asking me for the expected value. I know the formula is I simply multiply x times px and add everything, right? So payout amount, this is my x, this is my probability, which is px. So technically I'm multiplying this times this times this, and this times this. And I'm adding everything together to give me the expected value. What I'm going to do is I'm going to go ahead and open up your class calc and work this out in class calc. So here I have my class calc. So I'm simply going to do 140 times 0.101. So I went ahead and plugged in the class calc. What I want you all to notice is, even though this is a casino, even though you know the formula how to do it, just look at the math behind it. The probability of you getting $140 is 10%. The probability of you getting $2,000 is 3%. The probability of you getting $180,000 is 0.05%, which does make sense. Now, the expected value is, so if you play in the casino, what would you make? You would make $176.14. That is, you have to wait for the coins to be tossed, and the amount that you make, the expected value of the payout game, is $176.14. All right, now let's look at the next one. All right, so the next one is, once you finish calculating the mean of the discrete random variable, once you find out the mean of the discrete random variable, the next important one is to find the standard deviation. As you can see, the standard deviation, the way you represent this is, it's called sigma. Let me write that down. This is called sigma. The way you this is a Greek letter, and you represent this. So it goes around and then a line. It's called sigma. Now, you might say, Miss, why do I need the standard deviation? Once I have the mean, it's very important you find out the standard deviation, because you'll see what are the varieties that you have in that particular variable. And keep in mind, these values, mean and standard deviation, are very, very important in our daily life. The best example I can give you is your NFL players. If you have a chance, I would like you all to go ahead and look up the average of a NFL kicker and the deviation. So when I say deviation, the standard deviation, so let's say an example, an NFL kicker kicks 64 yards, right? I could be wrong, 64 yards. But if the deviation is 10, that means he can kick 54, which is 10 minus 64, or he can kick more than 64, which is 74. But you see, there's a 10-yard difference in there. So that's why it's very important to also know the deviation, not just the mean. All right, so now let's go ahead and look at how to find the deviation. So to find the standard deviation between the values and the mean, first you have to find the difference between the values and then square it, and then multiply the squares by the corresponding probabilities, add the product. So let me go back and do that. Step one is to find the difference, each deviation between the data values, square it, multiply the squares by the corresponding probabilities, add all the probabilities, and then take the square root. Let's go ahead and work a problem out. The table below represents the probability density function of a random variable x. Find the standard deviation of x. So here I have x. This is the x value. Probability is 1 over 5. X value, probability is 2 over 5. X value, probability is 2 over 5 again. So the first step is to find, remember what the first step is to find? Find each deviation between the data value and the mean. But I don't have the mean. Do you have the mean? Do you see something that says mean? Do you see something that says mu? I don't see it. So what do? I go ahead and find the mean. Remember how you find the mean? You simply multiply x times probability of x and add everything. So my mean mu is 0 times 1 over 5, which is 0. 1 times 2 over 5, which is 2 over 5. 8 times 2 over 5, which is 16 over 5. So I'm going to go ahead and open up my class calc. So I went ahead and plugged in. As you can see, 2 over 5 plus 16 over 5, I get 3.6. Where is it? I think I missed it. There you go. So my mean is 3.6. Once I have my mean, what is my next step? Let's go back and see. My next step is to find the deviation between the data value and the mean. What does that mean? So let me click on this. That means I have to find, where is my pen tool? I have to find x minus mu, the difference of x minus mu, and I have to square it. So this is my x, this is my mu. So it is 0 minus 3.6 squared. 1 minus 3.6 squared. 8 minus 3.6 squared. Okay? All right. So let me go ahead and find those values. I'm going to plug these in class calc and be right back. So I went ahead and calculated it. So please keep in mind that when you're plugging in your class calc, you should have your parentheses. So 0 minus 3.6 squared, I got 12. Oh, I think I lost it. 12.96. Let me go ahead and pull that up. And the next one is 6.76, and the next one is 19.36. So this was 6.76 and the other one was 19.36. Now once this is done, what's my next step? So I did find the deviation, that is the difference. I squared it, yes, and multiply. The next step is to multiply the squares by its corresponding probabilities. So what do? Once I have this value, I'm going to go ahead and multiply x minus mu squared with the probability. So here I am, 12.96 times, what's the probability? 1 over 5. 1 over 5. The next is 6.76 times, what's the probability? 2 over 5. 2 over 5. The next is 19.36. And the probability is 2 over 5. So let me go ahead and write the answers here. Let me go ahead, plug them in class calc and be right back. As you can see, I have plugged them into the class calc. So 12.96 times 1 over 5, I get 2.592. And 6.76 times 2 over 5, I get 2.704. So simply use your class calc. What I did is I did this whole step together. As you can see, x minus mu squared times 1.5, 1 minus 3.6 times 2.5, 8 minus 3.6 times 2.5. I did the whole step together. So let me go ahead and write these down. So this value is 2.592. I don't think I can move that far. And this is 2.704. And this is 7.744. Now my next step is to, so once I multiply, what's my next step? My next step is to add all of them and find the square root. So I'm gonna say, it's just gonna say step. So I have to add all of them. So 2.5, what was that? 92 plus 2.704 plus 7.744. Not only I add, once I add, I have to find the square root of all of this. So let me go ahead, plug that in class calc and be right back. So when I went ahead, plugged in, this is what I got, 3.611094107. Again, I'm assuming they'll ask you to up to 2 decimals or 1 decimal. So depending on what they're asking you, make sure you round it up. And again, I simply went ahead, plugged all of this in, added everything and found the square root. So when I go ahead and write it down, I'm going to keep it to 2 decimals. So 3.61 is my standard deviation sigma. So let's go over the steps one more time. First step is to find your mean. How do you find your mean? X times P of X. This times this, this times this, this times this. And what do? Add everything. And what do you get? You get your mean, right? Once you get your mean, what do? You simply subtract x minus mu. Where is your x? 0 minus 3.6, 1 minus 3.6, 8 minus 3.6. Your next step is to square it. Square, square, square. You get your answers, right? 6.19 point something. Once you get all of that, what do? Multiply each one of them with your probability. which is 1 over 5, 12.96 times 1 over 5, 6.76 times 2 over 5, 19.36 times 2 over 5. Once you get all your answers, what do? Add all of them up and find the square root, which gives you 3.61. Hope this helps. And again, if you have any questions, please make sure you take a screenshot of your photo of your problems and send it to me. And always don't hesitate to email me or contact me through Teams.